So physics, chapter 7, rotational motion. So to put it into context, so far I've been doing linear motion, right? Motion in a straight line. All we're going to do in this chapter is start talking about what happens when you go in a circular distance. So the first thing is, this guy right here, this is called angular displacement. And it really means distance traveled in a circle. Could it be more confusing? Angular displacement, distance traveled in a circle. So it equals the arc length, called S, what else would you call arc length, over R, which is the radius. So we have theta equals arc length over radius. And what is theta? It's the angular displacement. What's the angular displacement? It's the distance chewed out by some object traveling in a circle. So take a look at the first case. Everybody see theta 1 here? Theta 1. This is a small little angle. So does it chew out a lot of distance or a small amount of distance? A small. And the distance here is what? It's the arc length divided by the radius. Here's the arc length, and here's the radius. Here's the radius, and here's the arc length. S. And if it turns out that the arc length equals the radius, you get a radian. Woo, exciting. Which turns out to be about 57 degrees, for those of you inquiring minds. Now, what if the angle here, theta, is a lot bigger? Then you're going to take a lot more of that arc length, right? So basically, the angular displacement is the distance traveled in a circle. Instead of distance traditionally in a straight line, now we get distance in a circle represented by theta. In this chapter, it's got 3 Greeks, so stay with me. So theta is the angular displacement, and it's arc length over radius. Now, there's a conversion that you really need here. Revolutions to rads. Turns out that 1 rev equals 2 pi rads. So if we had 3 revolutions, if something travels 3 times around a circle, then how many rads has it gone? 6 pi. So you just go revs over 1, dimensional analysis, revs in the bottom, rads in the top. And we get 1 for the rev and 2 pi for the rads. So guys, everything's in rads in this chapter. If you're not doing rads, you're not rad. Your revs will not turn out to be correct. So don't do degrees, don't do revolutions, do rads. And you can see the revs cancel and you get 6 pi rads. So whenever you go from revs to rads, you'll always have pi in the sky driving along with you. Now the other conversion, over and above revs to rads, is RPMs. RPMs, old school, revolutions per minute. Turntables. Turntables, they didn't used to do that. They used to go around and around and around. So the old one was like 33 1/3 RPMs. Let's just do 5 RPMs. So we got 5 what? Revolutions per minute. Everybody see how to translate? Revs per minute? And then what do? Well, if we want to turn it into rads per second, first thing we do is put revs in the bottom, 1 rev, and how many rads in the top? 2 pi. And then revs are gone. And then we got mins in the bottom. So mins go to the top. And how many, 1 minute, how many seconds? 60. So we go 5 times 2 pi over 60. 5 goes into 60, 12. 2 pi over 12 is pi over 6. And you end up with pi over 6 rads per second. And if you're doing rads per second, that sounds like velocity, doesn't it? Ooh, rads per second must be velocity. So let's go Greek now. We did the distance, and what comes after distance? Velocity. And what comes after velocity? Acceleration. So, I'll come back to this in a minute. So, for velocity, what would you use for velocity? Well,
a weird W.
A weird W, exactly. Obviously. So, it's called omega or a weird W. Your choice. And the weird W equals, what did velocity equal old school when we were doing linear distances? Velocity equaled distance over time. So guess what W is going to equal? Distance over time. But what's our new distance? Angular displacement. So it's going to be theta, change in theta over t. So yay, we have a new formula now for angular velocity. Now think about this. Football game was on yesterday, yes, unfortunately. as it turned out for the 49ers. But nonetheless, a quarterback throws a football down the field. Down the field, old school, is linear distance covered, correct? But what's the quarterback going to do with the football as it's traveling down the field? Spin it. So now it's rotating, and the rotation rate is an angular velocity. So it's got two velocities. It's got a linear velocity going down the field, and it's got a angular velocity as it spins and rotates. Everybody get with the distinction? So we're just adding to our lexicon of physics stuff. We got a linear idea, now we got a rotational idea. And that's our rotation. W equals angular displacement over time. And then just as we have linear acceleration, anybody remember what it was? Old school, linear acceleration. Acceleration was?
Distance over time squared.
No.
Velocity over time.
Velocity over time squared. Remember, acceleration was velocity over time squared? So guess what the third Greek letter, the fish, is going to be? The fish is going to be, angular acceleration is going to be angular velocity, weird W, change in angular velocity over time. So we got three new things. We got a theta, we got a omega, and we got a fish, otherwise known as
Is that the weird W?
alpha. This is the weird W. This is the fish, alpha. And this, oh, this right here, yes, weird W. Let's go back and do it this way. Velocity equals change in distance over time, old school. And acceleration equals change in velocity over time, correct? So we just have analogs to those now. So this chapter may seem like it's full of all new equations, but in fact they're just analogs to linear equations. Linear equation is V for linear velocity. This is W for angular velocity. This is A for linear acceleration. This is fish for angular acceleration. The sound effects are provided as no extra charge. So look on page 246. We'll do a couple of these stretching exercises, warm up, get limber, and then move directly to triple turns. Page 246. By the way, did I mention, because we're dealing with velocities in a circle, everybody look. We're dealing with rotational velocities and rotational distances. It's just like trig. In trig, if you go this way, you're going positive. And if you go this way, you're going negative. So clockwise is negative, counterclockwise is positive. It really shouldn't come up in any kind of puzzling way, but just so you know. Okay, on page 247, number 3. 247, number 3. It says a Ferris wheel has an angular displacement of pi over 4 rads, which corresponds to an arc length of 29.8 meters. What is the Ferris wheel's radius? Do we have a way to figure this out?
Yes.
Do we have a formula with angular displacement?
What? Pi over 4 arc length equals radius times theta.
Right, and what's our angular displacement here? It's pi over 4?
Yeah, but isn't theta in degrees?
No, theta has to be in rads. Theta can't be in degrees. Theta has to be in rads.
You can't
Can't be in
such a
degrees.
big deal about.
Yeah, in math, it's like theta's always degrees.
Like our teacher is like a total Nazi about theta is
In degrees, yeah.
X is
Well, tell them to get kid-alike, because rads are much easier to deal with in mathematically. So we got pi over 4.
Silence, you can't do it.
What else do we have? Arc length is 29.8. Where does that go? S is arc length, of course. Wouldn't you call it S, arc length? Sure. And that's going to be what, 29.4? What is it,
29.8.
29.8. And can we find the radius? Sure. And all we do is cross multiply, and we get 4 times 30 is 120, divided by 3 is 40. because pi is just 3, right? We're among friends? No big. Good. Okay. Now look on page 248. Number 1. 248, number 1. It says a car tire rotates with an average angular speed of 29 rads per second. In what time interval will the tire rotate 3.5 times? Number 1. .29 rads per second. What's that going to be? Angular velocity represented by a W. And we know W equals theta over t, or change in theta over time.
We just do, yeah. Is it just 29 equals 3.5 over t?
No.
Dang it.
Because we got to go from
3.5 times.
these are revs. It says it revs 3.5 times.
Oh, okay.
So what do you have to do to a rev to make it rad?
Times 2 pi.
2 pi. That's all you do is 2 pi it. Remember I showed you how it worked dimensionally? All you just memorize the fact that all you
So
have to do
7
is
pi over t.
7 pi over t. So yeah, 7 pi. 3.5 times 2 pi is 7 pi.
Wait, sorry, can you just show me that 7 pi real quick?
Yeah, so the rotates 3.5 times.
Yeah.
3.5 revs. That's when it rotates 3.5 times.
Yeah.
That's 3.5 revs, isn't it?
Yeah.
And we know that one
Oh,
rev.
so 1 rev equals 2 pi. Right?
Yeah. One more time. I'm just going to write it up here so you can see it. 1 rev equals 2 pi rad. But now you can hard code it. Once you've seen that,
Yeah.
whenever you see a rev, you can just 2 pi it.
Okay.
So you get 7 pi.
Oh, you got it.
Yeah, always.
Okay.
And then you just cross multiply. 7 pi is like 21 over 29. It's about what, 3/4? So 0.75?
0.76.
0.75 what though? Just seconds, yeah?
Seconds.
Okay,
Can I open
cool.
one of these?
What's that?
Can I open these?
Sure. Haven't you seen one yet?
I'm gonna look at it again.
I must be distracted. Okay, now, we just did angular velocity.
As per usual.
We just did angular velocity.
As expected.
Now we're ready for
Angular acceleration.
angular acceleration. So here we go. Take a look at it. Top is spinning at 15 rads per second. And it spins for 55 seconds. Andrew, it's going to be distracting. Okay, I knew I should never have let open that thing. Okay, so it's spinning for 55 seconds before coming to a stop. What is its angular acceleration? Is this Tuffy?
No.
What's our formula for the fish?
Degree of W over T.
Yeah, changing W over
Angular acceleration.
T for
Do you
acceleration.
have a good way to remember it?
Alright, so it's
Wait, what?
Yeah, you have to memorize. You have to remember all
so
these.
remember
I
your-
know, but do you have a good way to remember it? Like,
Well, I just think of the old school and then change the acceleration
Yeah.
to a
Okay.
fish.
Fish equals A. It looks like an A, so therefore it's A. Like acceleration and angular acceleration, they both look the same. One of them is just a weird A.
Okay, whatever works.
Like the way that Shortenhouse draws it, and like if you look at it on our sheet, it looks exactly like an A, except there's like one more tail. See that? It's like it's just
Okay,
A.
fine.
No,
All
no.
The W is the thing that's confusing.
right, well, W is
just looks like
velocity.
a W on the paper.
All right, think about it this way. T U V W X Y Z.
Yeah,
So
except
W
W's
comes
coming
right after V.
X.
W comes right after V. So V old school, W new school.
Oh, theta is
V
X.
linear velocity, W angular velocity. Okay.
And then the weird O with the line through it is X.
Yes.
okay.
Theta is
Theta.
X.
Let's
Okay.
just continue. Let's
Theta.
move
It's,
on.
it's probably
I'm
more
trying to find
trouble
ways
than it's
to
worth to
remember
find an
Yeah,
analog.
just-
Okay.
Be creative.
Or just remember it as displacement.
Okay, so here we go. What do we do? All we do is 15 revs per second over 55 seconds.
No.
Guys, are you with me?
Yes.
15 revs per second over 55 seconds.
No.
Why not?
You have to have 2 pi, don't you?
There's no revs here. It's revs.
Ugh.
Oh, revs per second. You do. That's
Yes.
right. Yes, it's revs per second, not rads per second. Oh, good call. This guy's a quick study.
Telling me I was wrong.
Okay, sorry. Yeah, I wrote this too. 15 revs per second. What? Get rid of the revs. Revs in the bottom, rads in the top, and all we do is 2 pi it, right?
Yeah.
So we get 30 pi?
Yeah.
Yes, over 55.
Yeah, so we get
Is done.
30 pi over 55, and 3 times 90 is 3 times 30 is 90. 90 over 50 is like 1.8.
And then you need to put that over 55, don't you? Because that's just your weird
15.
W.
No, that's my angular.
We just times it by
And that's because theta always has to be in
What do you
rads.
mean?
Yeah.
Oh, you times it by 1 over 1?
No, but you're still missing a time there. 35 over 55 is just your W.
No,
No.
this is your time.
35.
No, 'cause
30
you're
pi
including it
is
per
your
sec.
is your revs per second.
Yeah.
Look, cancel my revs. I'm left with rads per
And in order
second.
to get W, don't you need revs, or don't you need...
That is
W is rads per second. W.
Alright, so that's just your W. 30
Blah,
pi,
blah, blah.
This is the W.
30 pi over 55 is W.
No, this
Oh.
is
Getting
Wait.
this is rad
Stop wasting
Wait,
that.
per
Wait,
second.
okay, but W is the change in theta over the change in T.
Yeah, but it's still rads per second already, so you don't need that.
Yeah, we've already got it. As long as you got rads per second, you're dealing with angular velocity. So it's rads per second over seconds, which gets you what? Rads per second squared, which is acceleration.
Yes.
Okay.
Okay, so 1.8 rads per second squared. Are we okay?
Yes.
All right, now with those 3 little things, those 3 little Greek formulas, we should be able to handle most of those problems that you're having trouble with tonight. So let's take a look at number 14.
Oh.
Or number 13. I'm going to skip 12 because 12 is just gay. I mean, sorry, retarded. No, please.
Every
camera.
time. The same joke.
Okay.
Just don't expect
I've got a routine. Anyway, all you do with number 12 is just do conversions. Yes? Can you guys convert? Sure. So I'm going to skip to 13. Here we go.
Do it
13?
for fun, though.
I'm sorry?
But nothing.
But it's not fun. It's just...
Wait, are we talking about homework right now?
Yeah.
Wait, yeah.
No, it's 212. I did
No, yeah,
not get number
212.
12. I did not get it.
How
It
about
did
we
not
take
make
2
any
minutes to try it
sense.
on our own?
Keep in
No, I
mind,
tried to do
this
it
is
before
regular
class, I
physics.
cannot
This
get
is
it.
the retard.
But this is retarded stuff. It's just...
That's
it's just
okay.
all right,
Okay, we're
We're
gonna
gonna
fine.
be able to do the retard
Look,
stuff before we
right,
do
look.
the normal
I'm
stuff.
a
The guys on the equator. Look, the guys on the equator. How long is it going to take him to go around the world once?
24 hours.
24 hours. In other words,
Wait, I
one
thought-
day. So it's going to
I
take
thought it
him.
said how long is it going to move in one day?
Yeah, well,
And how much time?
first of all, we have to find how long he's going to move, which is 1 day.
Oh, okay.
Now, how far does he move? Well,
Pi.
the circumference, which is 2 pi r. And what's r? Whatever he gives you.
Okay.
6.4 times 10 to the 6. So all you do now is convert from meters to seconds.
Wait, how do you know he's going to move the circumference? Oh, because it moves, it rotates.
Wait, what?
We're assuming that he's on Earth,
Alright.
and he's not an alien, and he has no rocket booster.
Alright, I take my
Wait,
question
is it
back.
2 pi times 6.4
Yeah.
times 10 to the 6?
Wait. Which planet are you on?
And that's going to be
You never-
meters.
He has to specify that we're on Earth.
But
Which
then
equation
guys-
are
Like,
you?
that's the thing. Sometimes he's like, what if you drop a rock on Mars?
I'm-
I want to
Yeah,
he
say
asks.
Yeah,
Okay,
So
what
sometimes it's
equation?
a trick question, and sometimes it's straightforward. And I always guess it's a trick question when it's just like what you would expect.
Here's what I'm using.
Oh, okay.
W equals theta over t.
So then it's
And theta is just the circumference.
I know my
Okay?
geology.
So 2 pi times, what is it, 6 point what?
6.4 times 10 to the 6 meters.
Okay, 10 to the 6 meters. And all I do is take days and turn to seconds. So 1 day is 24 hours. 24 hours is, you go days to hours to minutes to seconds.
Yeah.
I think it's 3,600. Is that right?
Times 24.
Times 24. So 24 times 3,600. And that'll get you meters per second. Okay, and the rest is just arithmetic. Are we good?
Yeah.
Okay.
3,600.
Yeah.
Wait,
It's just
how
how
come
far
it's
they'll move
24
on.
times
It's
3,600?
just 1 day is 24 hours.
Yeah.
And 24 hours is 60 minutes
That's
times
actually pretty
60
cool if
seconds,
you
which is
really understand
3,600. So you multiply this all together, you get seconds.
So it's asking for the angular velocity.
That is so weird.
Yeah.
But then isn't there a second part to that question?
No.
No.
What?
Oh, this thing.
Okay, moving on.
Why is that intriguing?
Just find the distance
Yeah.
and find the speed.
Well, the distance is just this top part, and the speed is just the top divided by seconds. Okay, that was an exercise in absurd futility. Okay, but Steve is happy now. Number 13, here we go. It says find the distance traveled.
Ignorance is bliss.
What?
Ignorance is bliss.
Well, now he's not happy because he's smart. So the next one, 13. Find the distance traveled by a point on the edge of a wheel with a radius of 0.4 if the wheel rotates through 60 degrees. So chopping this, radius equals what?
4.
0.4 what, meters?
Yeah.
Okay. And then it says 60 degrees. And both Steve and Matheson know that degrees are anathema. SAT word.
I'm already done with my SAT. I don't care about SAT.
Our college word. Forbidden. Okay, so what do we got to use instead of degrees? We got to use
Rads.
So this is like 60 is what, pi over 3, and that's what 60 rotates through 60 degrees. So
So that's S.
so that is,
Not theta.
well, I don't know. We want theta equals S over R. The R part is easy. That's 0.4, right? And the S is the arc length, and the theta is the angular displacement. So that's the only question here. Take a look at it and see what you think. It says the wheel rotates through 60 degrees. So that means it rotates through
Wouldn't that be S?
60 degrees. But it's going through the 60 degrees, so that should be the angular displacement. The 60 degrees is the angle that it's chewing up.
Oh, because it's asking to find the different distance traveled.
Yeah, the distance traveled is the S out here. When it goes through
When it
60
goes.
degrees,
Yeah.
it's going to travel this far in terms of S.
Okay, sure.
Yeah, that's
So you go pi over 3 equals S over 0.4.
Is this 13 or
13. And that's 4 over 5, so 4 pi over 15, that's 12 over 15, that's 0.8, 0.75.
The right answer?
Let's see.
Pi over 3 times what?
So you get 0.4 pi over 3, sorry, 0.4 equals 3s. Maybe I messed up here.
I'm not
Wait,
good.
why is it
0.4 pi equals 3s.
Why can't you just do...
So that's like 4 pi over
I'm just
5
looking for arc length.
equals 3s. 15s equals 4 pi. No, that was right. S equals 4 pi over 15. It's 0.75.
Wait, aren't they looking for arc length?
Yeah.
Yeah, wait, can't
Then
you...
how come you can't just do pi over 3
Times 0.4.
That's what I did.
I'm
Then how'd
getting,
you
I'm
get-
getting
I got
2.
0.42.
Yeah,
Oh.
same here. I'm
How'd
getting
you do
2 pi over
equals
15.
3s?
Oh, I see.
Why'd you
Yeah.
use S?
I can just do 0.4, can't I? Yeah.
Yeah.
The answer is 0.4. Sorry.
2.
So that'd be
Yeah.
about
0.4?
0.42.
Good God.
Yeah, 0.42. That's